Okay, so unfortunately, I am not able to get my computer to work properly now with OneNote, for the moment at least. And so I just wanted to kind of show you guys what the last example was going to be. And that was going to be example 9.5, or do not lift with your back. Okay, so what we can do instead is just kind of quickly walk through it. And then I might have you guys do this on the homework just to kind of make sure that you guys understood it. So we're considering a person lifting a heavy box with his back, and that is according to this figure here. Okay, so he's trying to lift this heavy box. And we want to calculate the magnitude of the force FB in the back muscles that is needed to support the upper body plus the box, and compare this with his weight. So it's very similar to what we were doing, okay? And they give its mass and the mass of the box, okay? So that's for part A, and then part B says calculate the magnitude and direction of the force F sub V exerted by the vertebrae on the spine at the indicated pivot point, okay? So let's go down here and look at that a bit. Okay, so we have, let me try to annotate. Okay. So we have this figure here, and we're trying to find first FB and then F sub V, okay? And they're at these different angles, so we'll have to watch out for that. Whoops. Remember that tau is equal to RF sine theta. So we'll be seeing that theta as not 90 this time. We're gonna have different angles here. Okay, and remember that angle is gonna be between R and F, okay? So let's see here. Let me try to erase this. Okay. So here, let's see, where are our pivot points? Oh, this is our pivot point here, okay, at the bottom of his spinal cord, or his spine. And we will need to, let's see, figure out the R, first of all, which, let's see. I'm sorry, this is a very tight graphic here. Let's see. Can't zoom in now. Theta between R and F. Which one is our R? Is it here? Oh, right. Okay, so this would be our R here for this first one. And then we'd have second one from this upper body and then to the box. Right, okay, so they're labeled. I'm just a little slow with understanding this figure here. Okay, so what we can do is we can do something similar to what we have been doing, okay, taking this net torque, setting that equal to 0. Okay, this is that equilibrium. Okay, and so we can do something very similar, and that's what I believe they have done. Okay, so they started to do that. So they had all of the, let me try to erase that stuff now that's in the way. Clear all. This is what they started to do. They have their F net in the Y direction, their net X in the F in the X direction. Okay, so then they did those. You have your y here. So they're just looking at the vertical components, and then they solve for that. So let's see, FVY. Yeah. Okay, so that's all they're doing, is what we were doing earlier. And then do the same thing with their x component and solve. And then to find the whole magnitude of it, they solve here. Oh, I just realized that that was for part B, my bad. But they do something similar for part A. Okay, so here we have the net torque, okay, for the weight, second weight, and then for the back, and then they solve for it, and then they get their ratio. That's what I was trying to do in the last video, and that's when the spinning wheel of death came on. That's the same idea, okay? And they do what I was just talking about for part B. Okay, so this was very short, and I apologize for my computer acting up, but hopefully that helped. I will be posting in the next day, or hopefully, and posting your assignments, including your lab and your homework. So let me know if you guys have any questions. I'll be available to email. All right, have a good one.